For our next panel, Matt Kaplan, who you've seen hosting our webcast all day, former head of Planetary Radio, is going to moderate this exciting session looking at kind of the precursors and updates on science. Basically, what science objectives do we need to be able to accomplish humans to Mars in the next few decades? So, Matt?
Thank you, Chris. And I guess this is working. Hi, everyone. One of the greatest things that I heard this morning, as we heard from all those representatives from NASA, is the degree to which science will drive human exploration of Mars, just as it's driving robotic exploration right now. And that it's one of those three legs of that three-legged stool, which is going to get us there. And so that's really what we're going to talk about today, both accomplishments and those precursors, as it says there, as Chris just read. So let me introduce, and we'll hear from each of them in turn. Lori Glaze, planetary scientist first, head of the Planetary Science Division at NASA. Welcome. Masaki Fujimoto. Whoop, I did it wrong because I got you here. I was so careful backstage to say 1, 2, 3. Didier Schmitt, strategy and coordination group leader at ESA, of course, the European Space Agency. Coordinates human and robotic exploration at ESA. Welcome, Didier. And now Masaki Fujimoto of JAXA, the Japanese Space Agency, Aerospace Exploration Agency to be exact, Deputy Director General of the Institute of Space and Astronautical Sciences at JAXA, which is ISAS, I think is how it's done. Okay, Lori, you get to go first. We got your slide working.
This was a last-minute effort to get this slide. You can go on to the next slide if you could, please.
But that's such a pretty one.
It is a pretty one, but this is the one that I love the most because this is the evolution of a Martian, and I think this really speaks to what you were saying, Matt, about the science that we've done and how that helps prepare us for the future and helps prepare us for hopefully eventually human exploration of Mars. And what you can see here is the series of robotic scientific rovers that have been to Mars over the last couple decades. You can see starting at the far left, Sojourner, building up through the MER rovers, Spirit and Opportunity, and then Curiosity, Perseverance, Mars Sample Return, and then eventually to the reason we're here talking about humans. And these robotic missions have really set the stage, really increased our understanding of the environments on Mars, so that's going to be critically important, but also helping us to understand what are still the questions that we have that really will require having humans in place on the surface to do some of those scientific science experiments that we'd like to run. We've actually just asked the National Academy to look at this to see what's the high priority science that should be done with humans when we go to Mars. So it's really set the stage. Just to kind of give you a quick update on some of these missions, I'll tell you Perseverance is doing a great job on Mars right now collecting samples. We've already collected 27 tubes, 24 of those with samples in them. 10 have already been deposited on the surface. We're carrying the rest of them on board. I think we've got about 12 more tubes left that we can collect. And of course, what we really want to do is get those samples back here on Earth. It's been one of the highest science priorities for more than 2 decades to get samples back to Earth from Mars. We're a third of the way there. Perseverance is there collecting those samples. Now we just need to get them back. So many of you probably know we have a Mars Sample Return mission. We were moving towards getting it confirmed last year in the spring and in the summer. But realized that before we took it to confirmation, we wanted to make sure that we had a cost and schedule that we could stand behind. We had it reviewed. They said that the existing cost and schedule wasn't going to get us where we needed to be. I'm going to leave it there for now, and I'm sure there'll be questions. We'll come back to exactly where we're going with Mars Sample Return going forward. But that's something that we're kind of in process right now. We're trying to find ways. Are there any ideas that we haven't thought of yet that will help us implement Mars Sample Return for a lower cost and less complexity, and perhaps even a shorter schedule to help us do that? I wanted to say beyond that, I just wanted to mention, really excited, I'm sure Masaki will talk about our partnership on the Mars Moon Explorer mission, which is a great mission, really excited about that. Our contributions have all been delivered to JAXA, and so we're really excited there. And then the last thing I just wanted to mention is our Mars exploration program, which has been around for quite a while now. we're working towards the future to make sure that we have a solid program that's going to go forward in parallel with Mars sample return and beyond. And I think I heard that Rick Davis is going to be speaking later this afternoon about one of the cool things that we're implementing there right now in the Mars exploration program, looking for commercial partnerships. So I think I'll leave it there, and we'll happy to take questions when we get there.
And that session is the one that you have heard from Chris is being added at the end of the day, 5 to about 5:30, and we're looking forward to getting lots and lots of your questions about how that MEP, Mars Exploration Program, is taking shape. Before we go on to Didier, I want to talk about, yes, Perseverance, Lori. Mm-hmm. I asked in a NASA press conference about Perseverance once, what would you guys do if you could, not to say that it would be possible, get Curiosity over there to that basin and join Perseverance with all of its amazing science capabilities built into the spacecraft?
Yeah, it has an incredible in situ laboratory with the incredible mass spectrometer that it carries is really one of a kind that's in an in situ location on Mars or any other planet. It is just an incredible suite. It's done amazing work at Gale Crater. It'd be wonderful to have it there at Jezero, but we have a pretty amazing suite of instruments on Perseverance as well. So we're doing some great in situ science in addition to the tubes we want to bring back.
Didier, let's go to you, and you've got some slides, I think, to present. We will come back to sample return.
No doubt.
for some time. Next one. We have a Mars program since some time. You know that we have some mishap with ExoMars. We had a relatively good start, but in 2014 we didn't get to the agreement with NASA, so we had to turn to our Russian colleagues at that time, and you know what happened 2 years ago. So therefore, when this happened, a few months before the launch, I told the team it's for the good, because now at least we have convinced all the member states to do the landing system ourselves, which is a good progress. So hopefully ExoMars is now also with the help of NASA for the launch, is on track for the launch in 28. Very, very big plus, of course, for the science, the deep drilling, deep 2 meters, which is quite extraordinary and something we have decided 20 years ago. We will come back to Mars sample return, but we're more or less ready with the orbiter for the return trip. So that is on track. We've got the budget. We've got the industrial teams in place. Something new on the left hand here that nobody has seen today because that's not public information. It hasn't been public information up to now. On the top, the Lightship project, which is not, so to say, agreed it will be blessed hopefully in 2 weeks, but I put the name already here, is a mission which will go to Mars and have an orbiter for telecommunication and navigation, and having a passenger spacecraft that will be put on a kind of 500 kilometers kind of altitude for very precision, high-level precision imagery. We absolutely need these type of missions because for the next step, which is on the bottom, the entry and descent landing, precision landing, we need these communication capabilities in the 2030s and obviously beyond. So we're committed to, we have started and we will start this first study. We will hopefully get the agreement in 2 weeks from now. I already put it on the chart here. To start also the other study on the entry, descent, and landing with the lander. The science on both missions will be decided in the coming months, and we will get out with a research announcement. So this being said, the next slide will show that hopefully that's only the beginning. What we aim at, and that's part of the strategy, which unfortunately is not yet public, is to master heavy landing, which when I say heavy, it has been mentioned this morning, 20 tons. hopefully by 2045-ish. So, and we're on the track to do this. So we need several orbiters. We need a lot of navigation communication, where we mastered this quite well in Europe. By the way, on the moon, we hope to have less than 1 meter accuracy with our moonlight capabilities. So we hope to do the same with Mars. And then, of course, heavier and heavier payload landings, science to be decided, and so on. And of course, for the 2 missions I mentioned that we are starting, we're completely open to collaboration for the payloads on board. The missions themselves we will do, so to say, in-house in Europe.
Thank you for allowing us to be among the first to see some of these still conceptual models for missions. Masaki, I'm going to go directly to you.
Okay, thank you. Can you show the first slide, which I cannot help
There it is.
showing? This is how we landed on the moon about 3 months ago.
Yeah.
Yeah, this is a mission by the name SLIM. It's a smart lander for investigating the moon. It's a small and smart mission. And at the altitude of 50 meters above the surface, it did demonstrate its pinpoint landing technology. The position accuracy was only 3 meters above at the altitude of 50 meters. So the remaining 40 seconds seems like a piece of cake. But what actually happened is something wrong with the thruster, and then it ended up in a wrong orientation like this. But still, it was a soft landing. We recovered all the data, and that's why we could reconstruct everything. And we knew that the orientation of the spacecraft on the surface of the moon must have been like this. But still, it's nice to have a picture like this. And the question is, it doesn't look like a selfie, so who took the picture? And if you go to the next slide, it's this guy. 250-gram-ish baseball-sized robot. It's been provided with help from a toy company, Takara Tomy, and then Sony. Well, Sony is a regular suspect, I guess, but it's the toy company who did participate in this program, and this small robot did a great job, telling us what really happened upon landing. So if you go to the next slide, what happened is that during the descent, even though it was in the contingency mode, during the descent, we released 2 small robots, and one of them was this Rev 2, and there was another one. And it's the smaller robot who took the picture, who took the image of the SLIM on the surface of the moon, and then transmitted the data to the other small robot. And the other small robot, which is only 2 kilogram-ish by mass, did the direct communication with Earth. So that's how we got that, I think it's an iconic image of our lander on the moon. And if you go to the next slide, so SLIM is like a precursor to our OK-sized lunar exploration, as well as for OK-sized Mars exploration. So SLIM demonstrates the pinpoint landing technology, which will be applied to MMX. And then we have an idea, or we have a concept, and we are starting to invest not a small amount of money into our Mars landing program. So let me try to explain each element. MMX, next slide shows what MMX is. It's a Phobos sample return mission. And unlike Hayabusa missions, we have to land on the surface and land still on the surface and do the sampling operation for 3 hours and then come back to the orbit. But in that landing process, we will utilize the pinpoint landing technology developed by SLIM. So that's the link. And then beyond MMX, this will be our first step in the Mars exploration program, but beyond MMX, by the way, MMX will be the humanity's first return trip to the Martian system, which we are very proud of. Precursor to Mars sample return, of course. But and beyond, we are trying to have a Mars landing program, if you show the next slide, which we will utilize new technology, a different technology, inflatable soft aeroshell. So if you want to land on Mars, you have to fight against the heat during the descent, and you also have to decelerate the speed, or descending speed. But in the Martian environment, the atmosphere is tenuous, so heating doesn't really matter. It's more how you slow down the speed is what matters more. So maybe an inflatable aeroshell. It's like Mary Poppins coming down with her umbrella in her hand. It works as long as the mass you want to bring to the surface is not too high. So different from NASA or ESA, we are really aiming at OK-sized mission. And for that OK-sized mission, this inflatable aeroshell can really do the job. So if you go to the next slide, our first demonstration of the technology will be bringing 3 small landers to the surface of the moon, like this. And the transportation vehicle, we call it orbit transfer vehicle, OTV, can be something common to be used by the second step or the third step, or even any deep space exploration led by us. So that, which means that our mission concept will be like on the next slide. Oh no, and then while we are thinking about this, came this alive and kicking of 2 robots on the surface of the moon. But if you think what they have done on the moon and modified a little bit, then on the surface of Mars, next slide please, it can already work. So there will be, it's not going to be a direct communication with Earth, but in the Martian environment, thanks to you guys, especially what you will establish soon, there will be a telecommunication system in the Martian system. So even a small robot, even with the existing technology, what we have demonstrated on the surface of on the moon, that will work in the Martian exploration. So with this big encouragement coming from a recent successful lunar landing, next slide please, we are thinking about bringing small assets to the Martian system, and even the small assets can really do the work thanks to all the infrastructures available. And yeah, this is what we are really thinking that the concept we have been having is not really bad. So this way, we can provide a nice platform for those people, those newcomers who can provide something, but who cannot build the whole mission. And Artemis, to me, Artemis is about let's explore Moon and Mars together. So big missions are nice. I hope you will make Mars sample return realized. So big missions set the framework, but there are a lot of things, like on Mars, so many places you want to explore before you send a human. So maybe NASA and ESA has been helping us a lot, but now we have become mature enough so that we can give back to the global community through providing this platform for small assets exploring the surface of Mars. Thank you.
Thank you. Masaki, you left out one of the most thrilling elements of SLIM for me, that this upside-down lander keeps on ticking. It keeps surviving the lunar night, which was not expected, right?
Yes, which was not expected. And so that's why I didn't touch on this. It's a pleasant surprise even for us. So I cannot be too proud about this. It's just a surprise even to us.
I think you should be extremely proud. And it gives me hope that maybe the lunar environment won't be as difficult to survive as
True,
we've
yeah.
been led to believe.
If you build the spacecraft carefully, this can happen. That's an encouraging element. Yes.
In the most self-serving way, I also have to mention, you couldn't see it in that angle, the artist concept of MMX. But one of those legs of MMX carries what we call, at the Planetary Society, my sister organization to explore Mars, PlanetVac, which is that other way that MMX will actually blow up. It's not a vacuum cleaner, it blows material up from the surface that we all hope will come back to Earth. And isn't MMX, in a sense, because of the thinking that material from Mars probably has ended up on the moon, that this is a sample return mission, at least we hope?
Well, it is a sample return mission, and it will be, as I think Masaki said, right? It'll be the first sample from the Mars system to make it back to Earth. And as you note, it's a possibility. There could be some Mars dust there, potentially. But it'll be pretty exciting, and certainly we're happy to be, as I said, really happy to be partnering with JAXA on this.
The way we came up with that idea is that we really want to make sure that we get any sample from Phobos. So we needed to have first we call it a backup system, and then Jim Green was really happy, so I changed the wording, of course.
Redundant,
two. We need 2 independent way of getting samples.
Yeah.
And the way, because it's a different way of getting samples, samples may have a different character, maybe. That's something we will learn after we get the samples. So it was about securing any samples at all, but then it become a more matured idea of,
Yeah.
yeah.
Yeah, so 2 sampling systems, which is great, and I think JAXA have demonstrated really well their ability to do these sampling missions and return samples through Hayabusa and Hayabusa 2. So they've got a lot of expertise in this area.
Didier, I cannot wait for that drill to penetrate the surface of Mars, because we've all heard so much about what might just be happening not very far below that surface.
Yeah, absolutely. I mean, our assessment, even nearly 2 decades ago, and all the simulations we did with all the radiation and over millions of years. So it's after 1.5 meters that you could have a chance still to have some organic material. That's why it's 2 meters. But obviously, that's not the end of it. We have to drill much deeper, and therefore the next missions, which will be heavier and therefore without parachutes, so we have to have other landing systems, aerobraking and so on, new engines, probably LOX methane engines. We have to land bigger masses, and that means if indeed deep drilling, which probably around 10 meters, maybe more, that's something we have to work together as well.
I also want to get your thoughts about what Lori told us about the status of sample return. It's obviously still very early in this process of reimagining MSR, but ESA, still a big partner.
Absolutely. I mean, we're fully committed. We have been working now on the Earth Return Orbiter for quite some time. We've got the budget. We have a 3 years cycle. It's not an annual cycle, so it makes sometimes things easier, sometimes more difficult. But at least the budget is secured. That's for the big part. And we are testing the engines. So for the electric propulsion, because we need to prove that we can withstand 3 years with these engines. So that's still ongoing. And we will diversify also the providers of electric propulsion as well in Europe, so that we have several options in the future as well. So we will be, so to say, specializing in this. And as I showed, the next mission is called electric propulsion tug. So we will use the same technology to tug spacecrafts around the moon, around Mars. Lower orbits, exactly what we'll do with Aero as well. Lower orbits, release another spacecraft, go back again. You have to be up for scientific and other reasons, telecommunications and so on. You have to be low with a passenger spacecraft for observation. So all these technologies we will, and we are mastering already now with Earth Return Orbiter. So we will build on MSR anyway, whatever happens.
We have only scratched the surface, if you'll pardon the pun, of what is happening at Mars, the flotilla of landers and orbiters out there. I'm thinking of the bandwidth challenges, Lori. I mean, MAVEN, in addition to doing wonderful research on telling us more about the atmosphere of Mars and where the water went, is also a communications platform, right? But we're going to need more than this.
Yeah, we will. We'll definitely need more. Right now, we do have still several spacecraft that are providing the telecommunications support. Certainly, Odyssey is still there, which is pretty amazing after 24 years, still kicking, or 23 years, I guess, at this point. And then, of course, beyond that, the Mars Reconnaissance Orbiter, which is doing a lot of the work for the communications. You mentioned MAVEN, doing great science still. We are also still working with ESA on Mars Express and on Trace Gas Orbiter that are still providing. But each one of those missions are starting to get a little long in the tooth. So we do recognize that in the future we are going to need additional telecommunications support. And I think that's something, again, that we can work together with our international partners, but we're also looking to partner with commercial companies, perhaps, right? There may be other models that we should be thinking about. How do we rethink how we provide that infrastructure support for the telecommunications?
So lots of robots, more to come. Precursors, that's in the title of the session. Getting us to the point where we have human footprints on Mars, human boots on Mars, although I've been told by some people that it's not good to say boots anymore.
We need more than footprints.
Yes. So where are we in terms of the science that is happening now that was already underway in terms of preparing us for that third leg of Mars exploration by humans? Lori?
Yeah, so I think we've made an enormous amount of progress, even just in the last decade, in trying to understand the environments on Mars. We've got on Perseverance, we ran several experiments to help lead us towards human exploration with the MOXIE experiment that was doing the transformation of carbon dioxide into oxygen. We also did some precision landing things. We also were testing some of the materials that are required, through testing the aeroshells to help us understand how they behaved in the system. So those are kind of technical advancements, but from the science side, better understanding of the history of Mars. So what kind of questions are we going to want to ask? And I think, on Perseverance, we've done an incredible amount of exploring of the crater floor of Jezero crater, which tells us a lot about the geologic history and climate history of Mars. We've explored the fan, which is giving us a lot more information about maybe the period in time on Mars when there was a lot of water, enough water to create the river delta that's there and the sediments that we've tested. We've seen the organic materials that are there, and we're now exploring up in the crater rim at Jezero, where we're finding incredibly carbon-rich materials, which is kind of enticing that we'd really like to get those back. And then eventually we're going to go out of the crater, and we'll learn even more about the history of Mars, its origin, evolution in that area where Jezero's crater exists. And I think that'll really help inform the types of questions that we want to answer.
Didier, where are ESA's thoughts about what is happening now, these precursors, are preparing us for putting people up there?
Well, a few elements. The first one we shall never forget, and I think the previous speaker, Eric, touched on this. The weak point is the human in the loop. We shall not forget about this. So from the technology point of view, from the landing part, we have to be able to co-locate at least 3 different landings. For the ascender, probably different from the lander itself, the human lander. Logistics, be it surface mobility and just landing on somewhere and staying there doesn't help much. So we have to have surface mobility. Energy has been mentioned also today. Will we put a mini nuclear reactor on the surface? I don't know, but we have to find a solution also for the mobility of the habitats and the mobility of the power systems. So the surface mobility is really the next big thing, and that we can test quite a lot on the moon. So I cannot make it public now, but we have a very fundamental reflection. NASA also will come out end of June with a white paper on lunar surface mobility, and we'll join forces there to see all the panoply of possibilities that have to be tested and used on the moon and then copy-pasted, so to say, on Mars. So landing, precision landing, surface mobility, and then I'm always reminded, I should think about it more often. I'm a scientist. I'm always reminded why. And that's, when you have 22 countries asking why every day. So it gets you thinking quite a lot. So the science aspect is very essential. But on the other hand, we're not, at least at ESA, the exploration program is not a science-driven program. It is an exploration-driven program, and whatever science we can do, we do. So we have another science program, which is more the sort of system science and astronomy, astrophysics. Our program is exploration. And whatever science we can do, again, we will do. But it's not the driver. We should not forget this.
Masaki, I want to let you address this as well generally, but speaking of surface mobility, seems to me I remember seeing a large pressurized rover that came out of Japan.
Yes.
A prototype, of course, a concept.
Yeah, I think there's going to be a talk tomorrow on that pressurized rover as
Yeah.
well. But that's really a huge one, and we demonstrate first on the surface of the moon, and then see if we can apply the same technology to the Martian system. But we don't just wait. We better do something while we wait for the development of the huge system. And that's the reason we are really interested in doing something with the smaller missions more frequently and more in a quicker way. And thanks to all the big missions setting the framework, even small mission with the focused topic can do a great job these days, because the context is set by the results from the bigger missions, and that's giving us a big room for smaller missions to play a substantial role in learning about the Martian system. So that's where we are now. So maybe a commercial company providing the smaller assets can make a big discovery. So I think that's the opportunity I see now. So big missions, you really have to make Mars sample return mission happen. But big mission sets the framework, and then that leaves nice room for smaller missions to play a role at a different time scale. That's the way I look. Then that will make us be prepared for human to Mars. That's the way I look at the current situation.
There will be other opportunities tomorrow to talk about what is represented by the three of you on stage, the international collaboration, cooperation that appears to be key to pushing basically all of planetary science and exploration of the solar system forward. But I wonder, Lori, there are a whole bunch of members now of the Artemis Accords, signatories to the Artemis Accords, who are not with us on stage. It seems like there's a new one or two every month.
It sure seems that way, and I think that's wonderful, because I really do think that, to achieve the big things that we're talking about, whether it be, a sustained presence on the moon, or whether it be eventually, the human presence on Mars, I think these are going to be the types of endeavors that require a global community, that we really all want to be working together for that goal.
Gentlemen, anything that you'd like to add before we go to questions from the audience? So if you have one, you can start getting ready to approach that microphone in the center there. The importance of international collaboration and to forward not just human exploration, but the science that we have seen such great results from already.
Yeah, absolutely.
Can I?
Sure.
Because of the recent success of the SLIM lunar landing, I want to have some reflection of what happened when it was emerging. We had a nice lunar orbiter by the name Kaguya, so it gave us a very nice data. And everybody was so excited, and they said, now we had orbiter, so next should be the lander. And everybody come together and it became a beefy proposal, and it didn't, that's the way it terminated. But there's a guy two people at the very core of that proposal who just stood up from the ash and said, it's not that I want to go back to the moon. I want to land on the moon. It's that I want to demonstrate the pinpoint landing technology. And that doesn't have to be a big mission. It can be a small mission. Yeah, well, in a sense, small mission is better, because if you demonstrate pinpoint landing technology by small mission, that's even better. So I'll always keep that story in my mind. Having the right shape of motivation. Everybody wants to be a part of Mars exploration. But not everybody can be a part of Mars sample return, directly a part of Mars sample return mission. But that doesn't mean that you have no role to play. And actually, if you want to send human to Mars, everybody has to be, in one shape or another, engaged. Otherwise, such a huge project will not be realized. So just try to do something. That's what I always keep in my mind. Yeah, I'm sorry for the primitive language, but
no,
yeah.
Very welcome. Thank you.
Absolutely. We have to do step by step. The problem with Mars, of course, is you can only go there every 22 months. But for example, we did a mistake in Europe. In 2012, we wanted to do a small lunar lander. I don't explain why it has been killed. And now we're full speed on a decent lander, 1.5 tons payload, without having done any landing before. So, and you're right, I mean, in JAXA, go do a mission as soon as you can, even if it's a small one, and then build on it. There's so much technology to be de-risked. And don't wait for the big thing to happen. First of all, it will always be delayed. Secondly, it's a decade of work. And then who knows what happens. So go to Mars whenever it's possible and do step by step.
First at the microphone there is Lori, your predecessor.
I know.
Planetary
Jim
Science,
Green.
former chief scientist of NASA. Jim Green?
So we're in a new decadal with fabulous sets of missions, and in the New Frontiers line, there is no Mars mission. So is the next Discovery call going to include a Mars mission or not?
The next Discovery or the next New Frontiers?
Oh, the New Frontiers, it's not in there.
Yeah, it's not.
So it has to come out
Yeah, and so
competitively. If you're going to have
yeah.
to do that, it'll be in Discovery.
Yeah, and Discovery is wide open. So,
Great,
you know,
thank
and
you.
as you are well aware, because you selected one, was a Mars mission in one of the previous calls. The InSight mission was, of course, selected through Discovery program. So, absolutely
we will
welcome.
Have a lander.
Will it have a lander?
We will have a lander.
Oh, you'll have a lander.
So
Yes.
you can
There we
include
go.
us in the call.
Yeah, absolutely.
Oh.
Yeah, excellent.
Anyone else? Hi, come on up.
Hi, this is for Issa. I was curious more information about your light. Your is it like how we were talking about? Like it's a demonstrator mission, almost like a tug in Martian orbit. Could you expand a little bit more on like what you're looking for out of that mission specifically? I know you touched on a little bit with your presentation, but I just wanted to get a little bit more information about that.
Okay, we can talk afterwards, but it's more than a demo mission. It's a real mission. And we will use the maximum capability of the Ariane 6 launcher. So it's a significant mission. So the orbiter needs to stay in orbit and do the comms and nav for hopefully a couple of decades. So we're working on the very long duration capability for communication. We have done it with TGO, so we know how to do it. The mission is really dedicated to prepare the next step, which is precision landing. So everything which has to do with precision landing, with the navigation and communication, and also with the high-resolution camera, we will develop all of this. The objective is the precision landing, and whatever science we can do on top, or with the instruments that we will be selecting, that's for sure. For the lander itself, the next phase, what we do on the surface is completely open for the time being. So we have a pretty good idea what we want to do. The tender for industry will go out probably in the second half of June, and this is where you will see exactly where we are heading.
Anyone else? Hi, come on up to the microphone, please.
This is for Director Glaze. So the nine companies that were selected to do industry studies for commercial Mars infrastructure services was certainly a big paradigm shift for NASA. And I'm wondering, for our international colleagues, if there's been kind of discussions like this to assist with Martian infrastructure or looking further in other planetary science kind of aspects. Thanks.
Yeah, and just to clarify, I think you're referring to the announcement that was just made about the commercial studies. These are going to be to look for public-private partnerships to provide various services for Mars exploration. So I think he's asking if ESA perhaps has any thoughts in that direction.
Which again will be the topic of that added
the one
panel at
later
5
this
o'clock
afternoon.
today.
Mm-hmm.
Yeah. Well, we are also in Europe in this trend of commercial services and so on. Of course, post ISS, obviously. Okay, the moon, I don't know. I'm a kind of fundamentalist. I think that exploration is institutional first. Whenever we can find opportunities for commercial aspects, why not? But you have to understand one very big difference. When we talk about commercial in Europe, and it's real commercial, I have the tendency to think that in the US, when the US talks about and NASA talks about commercial, It's just the way we handle any contract, which is firm fixed price. If we exceed by 10, 15% over many years a program, that's already outrageous. I don't talk about the multiple factors in the US that happens, because we have firm fixed price. And this for you should be commercial. Firm fixed price, commercial. The other part of commercial, making businesses and so on, honestly, that's not really something we look into it, we will support it, but we don't build a strategy on it.
Masaki, anything to add?
After the successful landing of SLIM, there's a big pressure from the government of Japan telling us that we should transfer the technology to the commercial partners. So likewise, we will do the same for our Mars landing technology. So we are happy to be the first to demonstrate the technology, and if there's any interest in commercial partners, we're happy to share.
And with that, if we can, one more, if we can be very quick.
Okay, I'll be quick then. I had one question. I was wondering, what specific technology jobs were you thinking of giving to commercial partners?
Okay, through the commercial program that, again, there's going to be another discussion more full this afternoon, but the kinds of things that you could envision are either providing data relay. We could have spacecraft there that we would buy the service from the commercial company to do a data relay for us, so they could be able to receive the data from the rovers on the surface and then relay back to Earth, and we would pay that commercial company for the service. So it's those kinds of things that we're talking about.
Okay, thank you.
Thank you. Thank you, everyone, and especially the three of you, Lori, Didier, and Masaki. Didier, I will happily welcome you back to the stage tomorrow for another session. And Chris is back to move us along.